This exercise serves to show you how we can reduce fractures. Now, reduction is actually just the recreation of the spatial relationship from one fragment to another. What happens when a bone fractures? The bone loses its integrity, meaning the muscle pull serves to shorten the bone and to malalign it. So this is what we have to recreate, is the original position of the bone. And we do this by distraction and manipulating the main fragments. And I'm going to show you how to do this indirectly and directly. And I'm going to show you a few instruments with which we can do these things. We have different reduction clamps. This is a pointed reduction clamp that I will demonstrate to you. You can overcome translation with this pointed reduction clamp. Then we have a standard reduction clamp, and you can see by the size of this, you can put a lot more power into this. So you can overcome translation, and you can also manipulate the bone, maybe in a rotational way. There are other pointed reduction clamps that can be used in special situations in order to hold a secondary fragment, for example. Now we have a plate holding clamp, and this plate holding clamp serves to hold the plate to the bone, and sometimes we can even use this clamp as a reduction tool for direct reduction of two main fragments. We have more special instruments for direct reduction. One, for example, is the Farabuff clamp, and you see the jaws of this clamp have a very peculiar form. Now we can use this to manipulate translation, and we can correct rotation. We can also compress with this instrument. We have another instrument that can apply a lot of power on two main fragments, and this works by fixing the clamp to the bone with screws, so that not only can you compress, but you can also distract and you can manipulate translation. Here we have what we call the collinear clamp. We have an open reduction internal fixation. We have already placed a plate. Now I can manipulate these fragments using a variety of instruments. For example, the pointed reduction clamp. You see, I have fairly good manipulative power in order to move the fragments into the direction that I want to move them. Sometimes the pointed reduction clamp is not strong enough in order to overcome translation, and sometimes, therefore, we use the standard reduction clamp. So you see how I can manipulate these fragments using the standard reduction clamp. This also has an advantage. If I need to overcome translation in a different axis. Now I can manipulate the fragments in this direction, as you can see. These are examples of direct reduction. Now I want to show you examples of indirect reduction. For example, in this oblique fracture of the distal tibia. As you observe, we have one screw outside of the plate. This is called a push-pull screw. Now, if I know that I still have shortening, I can use the bone spreader, place the bone spreader in this manner between the screw and the plate, and I can manipulate the length of the bone. Once I have done this, I can actually put the same fracture under compression by using the small plate holding clamp, which is placed in this direction. In this way you see how I manipulate the length of the bone under compression. This is a model of a femoral fracture which has been dislocated because of muscle pull. There is an ideal way of reducing this fracture, first of all by traction or distraction, and then fine-tuning or manipulating the main fragments. Now I have already applied the femoral distractor. As you can see, the femoral distractor is connected to shank screws. And the closer we can get the femoral distractor to the bone, the more power we have with which we can manipulate. That's why we have two different lengths of sleeves for the shank screws. Once I have applied the femoral distractor to the shank screws, I can tighten these nuts because I have different ways of applying this distractor so that I could actually mobilize this in all axes of movement. Now, if I want to distract, all I need to do is use this nut, and the distraction power here is transferred to the shank screws, and they distract in order to correct the length. Now you see there is still a significant amount of dislocation. What I can do now is loosen this nut, apply the T-handle chuck. Now you see that I can manipulate the main fragment. I can align it to the distal main fragment. Now I need to correct length, and I do this by using the femoral distractor. Go ahead and take the nut and now start using this. Okay. And while he is doing this, you can see, keep going, that I am correcting the length. And if I continue this, I can actually put this oblique fracture under compression if I like. Stop. But I have now reduced the fracture that I can now either plate or apply a nail to. I want to demonstrate the use of the collinear clamp in order to achieve direct reduction. And if I use the collinear clamp through the skin and through the muscle, I can place it in this direction and in this position. And now if I apply compression, you can see just by using the clamp that I actually can reduce the fracture while putting it under compression. Now all I need to do is manipulate one of the main fragments for fine-tuning the reduction. One more point I would like to make is utilizing the T-handle chuck and a shank screw as a joystick. When you see this pelvic fracture, sometimes there are forces that you have to overcome using a good bit of leverage, and you can do this with this joystick. I can combine methods of reduction and instruments, for example by using the joystick in combination with the Faribault clamp like I have right here. And once I have manipulated my fracture to where I would like to hold it, then I use the Faribault clamp in order to achieve compression. So with the remaining time we have, I would like for you just to take a few of these instruments, play with them, and see why we call them instruments of reduction. Now if you like, just use